Right.
Sir, we
So
started off motion.
yeah. So we started laws of motion, and in laws of motion we understood about law of inertia, right? So we were talking
Yes, sir.
about laws of motion. So first law was the law of inertia, right? Law of inertia says that when force is zero, right, then V is constant. So this was law of inertia, right? And then
Yes, sir.
the second law, then the second law says that the force is equal to rate of change of moment, right? Or rate of change of momentum. And this force is in the direction of rate of change of momentum, where the momentum is changing, because this is momentum. This is a vector quantity, right? So wherever the momentum is changing, that is the direction of the force. So this we understood, and then we saw that this force is mass into acceleration. So this we did, right? And we understood that this momentum is product of mass into velocity, right? So up to this point, we understood. Now, now let us talk about the third law, right? So you guys already know the third law. So third law is action and reaction are equal and opposite, right? So it says that if some object is applying some force on the other object, then that the other object will apply the same amount of force, but in the opposite direction. So that is what the Newton's third law says. So let's say that we have two objects. This is A and this is B. So this A is applying some force on B, right? So this is FAB. So force, let me write. So this is force on A due to B. So this is this one, right? So force on A due to B, which means that force applied by B on A, this would be equal to force on B applied by A, but with the minus sign. So this is what we call the third law, right? Remember, this minus sign is important. So this is what we call the Newton's third law. Any doubt in this, guys?
No, sir.
Yeah, and we will see that what is the use of this Newton's third law. So we'll when we'll study the collision, so then we'll understand that this law gives the conservation of momentum. So when we'll talk about that conservation of momentum, then we'll talk about this again. But for now, only remember this, that whenever we apply some force on the object, then the object will apply the same amount of force, but in the opposite direction. So action is this. Action is that this A object is applying some force, but the reaction is this one, right? So this is what we call the Newton's third law. Okay. So now we know all the three laws, right? These are the important laws of motion. And then the next thing that we'll learn about is the impulse, right? Okay, so what is impulse? So whenever some force is acting for a very short amount of time, right? So whenever some force is acting for a very instant, at instant that force is acting, right? So from that we'll get the impulse. So what is impulse? So to understand impulse, we should understand about the impulsive force first, right? So force which is, or let me write it as the average force which is acting for a very shorter duration. Okay. So can you guys think about that kind of force, impulsive force? That happens very quickly. Yes. Can you guys think about that impulsive force that is coming into your mind? Any example that you guys can think of?
No, sir.
Okay. So striking a nail with a hammer. What is the spelling of it? Did I write? Okay. So this is one example. When you strike the nail with the hammer, so the hammer applies a very short amount of force, very short duration force on the nails, right? So
Yes, sir.
that is called the impulsive force. Or let's say the batter applies a very short duration force on the ball. So whenever the batter strikes the ball, so he applies a very short duration force. So that is called the impulsive force, right? Or a batsman strikes the ball. So these are some example of impulsive force, right? So we have a force and it acts. So this is zero, and then at certain it acts, and then it goes zero, right? So we get a very quick bump, and then it is zero. So this is called the impulsive force. Is this clear, guys?
Yes, sir.
Okay. So similarly, the other example would be the ball striking the ball, right? So this is what we call the impulsive force. So from impulsive force, we can define the impulse, right? So impulse is defined as impulse is defined as the impulsive force acting over a period of time, right? So I is I is impulsive force into T. Okay. And what would be the SI unit of this impulsive force? What would be the SI unit? Can you guys tell me what would be the SI unit of this impulsive force?
Meter per second?
Per second. So this is into time. Absolutely, you are going in the right direction. F is Newton. Time is what?
Yes.
Second, right? So this is Newton second.
Yes.
Good, good. So these are the things that is about the, and it is a vector quantity or a scalar quantity. Impulse. Impulse is what? A vector quantity or a scalar quantity? Yes, guys, what is impulse? So you guys can see here. This force is a vector quantity, right? So this is multiplied by some scalar. So impulse would be a vector quantity. Okay. So please, if you guys have any question, please ask. Otherwise, please note it down. And whenever you guys want me to scroll down the screen, guys, so this is average force. Yeah, whenever you guys want me to scroll down the screen, guys, yeah. So please tell me whenever you guys have noted it this much
Finished, sir.
finished, then please note it down. Impulsive force.
Finished, sir.
Finished. Ishida, Ilham, Amna, what about you guys?
Yes, sir. Done, sir.
Okay, so
Done, sir.
let us do one question to understand this problem. So a batsman strikes the ball with, let's say, uh, 50 Newton force in 0.01 seconds. So, what is the impulse imparted on the ball? Right. Please calculate and tell me the answer. What is I? This is F into T. So please calculate and tell. So you see that it is for a very short duration, right?
Yes, sir.
What is the impulse did you guys get? Yes, guys. This is straightforward calculation.
So 0.5.
0.5 units Newton second, right?
Yes, sir.
So 50 into 0.01, which is 0.5 Newton second. Yes, so Amna also got zero point 0.5, right? So this was a very simple, quick calculation, right? To calculate the impulse. So is this clear, guys?
Yes, sir.
Yes, Rishida, Ilham, and Amna.
Yes, sir.
Okay, now this impulse is also related with moment, right? So relation between momentum and impulse. Okay, so we know that impulse is F average into T. And what was the definition of F average? Do you guys recall?
Newton.
No, no, no. I'm saying what was the definition of F average? What was the second law?
So
F
second law
equals
it
to
was
Yes, yes, Rishita, you were saying something.
F equals to MA.
MA, not MA, not MA. So what was the second law? Right?
delta P by delta T.
Yeah. So MA is also correct, right? MA is also correct. But we derived MA from the previous, as Akib is saying. From this law, we derived F equals to M, right? So this is also delta T. And this is the change in time, which is delta T, right? So this delta T cancels, and impulse is what? This is simply delta. So if I write it in this language, so I is P2 minus P1, right? Or P final minus initial. So impulse is also defined as, so impulse is also defined as change in moment, right? So you guys can see from here that what is the unit of impulse? Newton second. And what is the unit of momentum? Right. What is the unit of momentum? So F is P by T, right? dP by dt. So this is Newton and second. So this is Newton second, right? So you can see from here that it is related with this impulse. Okay. So yeah. So please note it down. If it is not clear, then please ask. Is this clear, guys?
Yes, sir.
Yes. Rishita, Elham, and Amna. Clear?
Yes, sir. Yes. Sir. Yes.
Okay, so please quickly note it down and then we'll do one question based on this. But before this, I will ask a question related to vector and I will check whether you guys remember or not. So whenever you guys have completed noting it down, please tell. So whenever you guys have completed noted everybody.
Yes, sir.
Done.
Okay. Now, yeah. Now, before I start the next question, so you guys tell me that, let's say I have this vector. This is my x and y coordinate, and I have this vector which is whose magnitude is 3, right? And this angle is let's say 60 degrees. So how can I write this vector in the Cartesian form? Before I tell you guys, so what is the vector in the Cartesian form? In two dimensional.
Ax
Yes,
I cap plus ax y j cap.
absolutely right. So this is we know, right? Everyone?
Yes, sir.
Yes.
Yeah. So now you guys know this. So this part, this is resolution of vector. So the magnitude of this vector is 3 and the angle it is making with the horizontal is 60. So can you guys tell me what is this A vector? Please tell what is this A vector? So let's see you guys are revising about.
Twenty.
Yes, Nishita, what did you say?
20.
20. What is this 20? A vector.
No, sir. One second.
Okay, so let me give you guys you have to find out what is AX and what is AY, right? So then you can write vector as AXI and AYG. So this much hint I can provide you guys. This you guys have to know instantly, right? These kind of question you guys have to know instantly because this is the basic question of vector, right? And there would be so many questions based on this. So you guys please revise the vector part, right? Yeah, do you guys remember now?
Doing, sir.
Okay. Elham and Amna, what about you? So we did uh, we did in the backup class. We did this part, right? Elham and Amna.
Yes, sir.
Yes, sir.
Okay, so please, uh, what would be this EX and AY? Please find out, right? Because the next set of question is based on that. Otherwise, so if you know this part, then it would be easy for you to calculate that part. Okay. Okay, should I tell you guys? If you're not remembering, you guys please revise. And we can write AX as, if you remember, this was A cos theta. And AY was, this was the vertical part, this was A sin theta. Magnitude of A, we know, this is 3. And cos 60. Cos 60 is what? 1 by 2. So this is 3 by 2. And A sin theta, which is 3, and sin 60. Sin 60 is root 3 by 2. So this is 3 root 3 by 2. So then we'll have what? AX, which is 3 by 2I, and then this is 3 root 3 by 2j. So this would be our vector. Is this so now do you guys remember?
Sir, I by mistakenly plused both of them instead of doing I and J.
Oh, so yeah. Did I do any mistake?
No, sir.
Oh, okay, so yeah, please you guys do the revision, right? Because the school will reopen soon and then they will take some exams. So this part, always remember that vector and calculus. So these are the crux of your whole 11th class. These two things you guys have to remember in your mind or in your hand, right? So these two are very important. Okay. So is this clear, guys? Is this clear?
Yes, sir.
Okay. Now let me ask one more question. I am asking this question because okay. So if I say that I am moving in x direction 5 units. So what would be my vector? What would be my
Sir,
vector?
5I.
5i, right? Good. And if I am moving in, let's say, j direction, let's say 3 units, so then this would be 3j, correct?
Yes, sir.
And if I am moving like this, right? If I am moving like this, then there be x component and y component. And then we calculate like this. So again, if you have this kind of motion in this way, so this is your velocity, right? So let's say that this is 20 meter per second, right? This is the magnitude and the angle is 30 degrees. So you guys tell me what is this v velocity? Quickly calculate and tell me. This is x and this is y. Did you guys understand this problem?
Yes, sir.
Okay, so please, yeah, calculate this. Yeah, Rishita, Ilham, Amna, you guys calculating. Yes. Are you guys calculating?
Yes, sir.
Okay, cool. So calculate and tell me. This is very important. Why am I asking you this? Because the next question is based on this. Yes, anybody got the answer?
Calculating, sir.
Yes, Rishita, Ilham, Amna. Any answer, guys?
No, sir.
Any confusion? So what is the thing that we have to calculate? We have to calculate the x component and y component. This part, right, guys?
Yes, sir.
And did you calculate it, the x and y component? Vx and vy. So this is v cos theta. This is v sin theta. Right? This much, did you guys reach this point? What is magnitude of v? What is magnitude of v? This is
20 meter.
20, right? So 20, and then cos of 30. So 20 cos of 30 is root 3 by 2. So this is 10 root 3, right? And v sin theta. V is 20 and sine of 30. So 20 and half. This is 10. So this is 10. Now v would be what? Vx I hat and vy, and this is positive, so this is I hat. This is what? J or minus J? Yeah, this one is in which direction? J direction or minus J direction?
Minus J, sir.
So this is minus J hat, right? So we have Vx, which is 10 root 3 I hat, and then we have Vy, which is minus of 10 J. So this is my velocity. Clear, guys?
Yes, sir.
Okay, so now we will be, yeah, Elham, Rishita, and Amna. Is this clear?
Yes, sir.
Quickly note it
Yes,
down and
sir.
then, yeah, quickly note it down and then we'll do the question. Quickly note this down and then we'll do the next question.
Done, sir.
Done. Okay, so the next question is that we have two scenarios. So first we have to calculate the impulse on the ball when it strikes the ball and turns back right perpendicular to the wall with v velocity. Okay, so this is what we need to calculate. The pictorial diagram is what? So we have this ball, okay, and we have this, right. So we have this ball which strikes this wall and then turns back, right. So first it strikes this wall and then turns back. So we have to calculate the impulse. So what do we know? What is impulse?
So Newton second.
Yeah. No.
NS.
So this is a P2 minus P1, right? And the mass of the ball is, let's say, mass is 0.05 kg. Okay, so this is the mass. Or if yeah, so this is the mass of the ball. So we know that the impulse is this, correct?
Yes, sir.
So the the ball is going in this direction with v velocity. Okay, so what is v1? What is v1?
So it will be positive.
Yeah, so it will be positive. What this vectorial? This is vectorial representation. So what is v in this
I.
direction? Yeah, so magnitude is v. So this is what you say when I ask this question, right? When I
Yes,
ask
sir.
this question, so you said 5i. So we have v, so vi. Clear?
Yes, sir.
Now the ball is returning back with v velocity. So what is v2? What is v2?
minus V J cap.
So it is going upward or in the same direction it is, in the opposite direction. J meaning that it is going upward, right, Amna?
Minus V I cap.
Yes, absolutely right. So minus vi. Is this clear, guys?
Yes, sir.
So P2 would be how much? This would be M and P2. So M is 0.05, which means that it is a 50-gram ball, right? So 0.05 into this V minus VI. So minus VI, which is minus 0.05 VI. And what is P1? So MV1. This is 0.05 into VI. So this is 0.05. Is this part clear, guys?
Yes, sir.
So now
Yes,
we
sir.
have to calculate the impulse. This is P2 minus P1. Right. So this would be minus of 0.05 VI and minus of 0.05 VI. So this is 2 into this, so 0.01, right? And I, or this is BI. Okay, so this is our answer. Is this clear?
Yes, sir.
So this is the impulse imparted to that point, right? If I calculate the magnitude, so this would be minus of 0.1. Okay, minus signifies that it is in the opposite direction. So impulse is in this direction,
Yes, sir.
right? Okay, so is this clear, guys, or do you guys have any question?
Yes, sir.
Clear, sir.
Clear. So please note down this part. Please note down. Oh, what is that? So I can give the value of velocity as well. So I can say that the velocity is, let's say, 20 meter or 50 meter per second, like that. So
Yes, sir.
yeah, so in some question they can also give you the value of the velocity.
Yes, sir.
Whenever you guys want me to scroll down the screen, you guys tell.
Finish, sir.
Finished. Okay. So then note down this. Everyone, whenever you guys have noted it down, please tell.
Finish, sir.
Rishida, Ilham, Amna, what about you guys?
Done, sir.
Okay, now we have the same scenario, but a change in the question. So same question, I will not write the question, but I will just draw that part. I have the same word, but now what is that? So I have the same ball, but the ball is striking with some axe. Okay, so this is how the ball is coming, and then it's striking with 30-degree angle, and then going back with 30-degree angle. Right. So this is the velocity with which it is striking, and then this is the velocity with which it is turning back. Right. So then in the same question, we have to find out what is the impulse. Impulse meaning what is the uh, momentum change. Clear, everyone?
Yes, sir.
Okay, so let me draw this diagram. We have to figure out, right? Remember, we have to follow the same process, but we have to figure out V1 and V2 first. Clear, guys?
Yes, sir.
Okay, so let's say we are at here, right? So in here, the vector is this. So it will have, let me draw it here. So the vector is this, the velocity, and this angle is 30. So what would be this angle?
30.
30, right? So let me draw it in. So we have this angle and this one. This is 30. This is V. So what this is V1, right? Which is magnitude is V. So what would be V1? Can you guys tell me? We have done this problem. Just exactly the same problem we did. So I will write the answer, right? I will write the answer. So this is V cos 30 uh, I hat, and then minus of V sine 30 J hat. Is this clear, guys?
Yes, sir.
And for the case of V2, so in here I have this V2, right? So this is my V2 with a V velocity, and then these are the components. Okay, guys. So what would be and the angle, right? So this is 30. So this would be 30, right? This is 30. So what would be V2, guys?
Sir, same, right?
But we have this.
Minus V cos
Yeah,
I.
absolutely right. Good one. So minus V cos theta I and
Sir, then it
minus
will be plus because
which
this is
one?
going down, right?
Yeah, this is going down, right? This is going like this. So this is going like this. So it will have this component and this component, right?
Yes, sir.
So this is minus j and this is minus I, correct?
Yes, sir.
So this is minus sine theta j hat.
Sir,
If
can't you just directly write plus in between?
plus in between, which one plus?
Like minus V cos I, then plus V sine theta j. Because it will be minus j, right?
Yeah, so minus j, so this is why this is minus, right? This is minus j. So why would there be plus in here?
Oh, okay, sir.
Okay, clear everyone? Is this clear?
Yes, sir.
So now, if I calculate the impulse, so impulse is m would be same, right? V2 minus V1. So m is same, right? This is V2 minus V1. So m is taken outside, and then V2 minus V1. So this is m. V2 is what? Minus V cos theta, and I hat minus B sine theta, J hat minus of V cos theta, I hat minus V sine theta, J hat. Okay, so this is M and minus V cos theta, I hat minus V sine theta, J hat minus V cos theta, I hat plus of V cos theta, V sine theta, J hat. So which part is getting cancelled? Can you guys tell?
Sir, sine theta.
Sine theta, right? So absolutely right. So sine theta is getting cancelled. So whenever you guys see that these kind of questions, the ball is striking the ball with some angle. So you guys can see that which part is getting cancelled, which component?
Sine theta j.
J component. Y component will get cancelled, right? So always remember this. So we will get the impulse, which is minus 2m and v cos theta I. Okay. So the magnitude would be how much? This would be minus of 2, m is 0.05 v, and cos of 30. So cos of 30 is how much? Root 3 by 2. So minus 2, 0.05 v and root 3 by 2. So this cancelled, and we have this is minus 0.05. This is the impulse. Okay, is this clear, guys?
Yes, sir.
So please, if you guys have any doubt, please ask me. Otherwise, please note it down. So please note it down.
Yes, sir.
And whenever you guys want me to scroll down the screen, guys,
Finished, sir.
finished. This one also finished.
Finished, sir.
Finished. What about you guys, Rishida, Ilham, and
Done, sir.
Amna? Okay. Yes, Rishida
Yes,
and
sir.
Rishida, what about you? Completed?
Yes, sir.
Okay, so the third question is that what is the ratio? But before I do the third question, so just remember, whenever we have whenever we have these two, right? So the ball strike with some angle. Let's say this is theta, right? So whenever we calculate the momentum change, so whenever we calculate the momentum change, so which part will survive? Only the cos theta component will survive. So you can directly write it as 2 mv cos theta. If I write directly, did you guys understand this part?
Yes, sir.
Okay, so you can directly write it, right? This I wrote it like this so that you guys can understand, right? But you can directly say that this will have the cos theta and sine theta, and this will also have sine theta and cos theta component. But sine theta will be cancelled, and we have only cos theta. So cos theta component in here, right? And then in cos theta component in here. So this will give you minus 2 cos theta. Okay. And for the previous case, what you guys get? For the previous case, you guys got minus 2 mv, right? When the ball was striking like this and returning back. So this is
Yes,
what you
sir.
got, right?
Yes, sir.
Okay, so you guys can see it from here also that you got what you got minus 2 m, right? So then what we can say that if somebody asks you, the third question is that what is the ratio between the impulse imparted in both the cases, right? So for returning back, the impulse was minus 2m, correct?
Yes, sir.
And with the theta angle, with some angle, this was, let's say this is I1, this is I2, this was minus 2 mv cos theta. So the ratio would be I1 divided by I2, which is minus 2 mv divided by minus 2 mv cos theta, which is this is cancelled, so we have 1 by cos theta. Is this clear, guys?
Yes, sir.
Yes, sir.
Okay, please note it down. Please note it. So this was the question of the NCR. Noted, everybody?
Yes, sir.
Yes, sir.
Okay, so now the next topic is the general forces in our nature. Um, so the first one is the very trivial one that you have encountered so many times. Yeah. So the first one that you have encountered, can you guys tell that? What is that force? So the force which is experienced by me, the force which is experienced by you, the force is which is experienced by the moon itself. Can you guys think about that force?
Sorry, sir.
Yeah, so that force is experienced by you, which is you are experiencing right now, and the chair that you are sitting on, so that is also facing that same force. And the car which is traveling, I am sitting here, so I am also experiencing that force. Even the moon is also experiencing that force. So can you guys tell me about that force?
Gravitational force.
Yes, gravitational force. So the force exerted by the earth, right? Gravitational force, right? So the force with which earth is pulling at the center, right? So we have this surface, right? And in here we are experiencing at the center, right, this force. And let's say somebody is in Australia or something like that, so he is also experiencing the same force at the center of the earth, right? So somebody is here, so he is also experiencing the same force in here also, same force, same force, right? So this is the force that is experienced by everyone, and this is exerted by earth to us, right? So what is the amount of force? Let's say some object is sitting here. So it is pulled by the earth, right? And its amount is mg, right? So this is the Earth's gravitational force. Is this clear, guys?
Yes, sir.
Right. Okay. So this is always in the direction of the center of the Earth. So it is directed along the center of the Earth. Right. So this is what about the gravitation. Now, let the second force which we experience in daily life is the normal reaction. Right. So what is this normal reaction force? So whenever two surfaces are in contact, or whenever an object is in contact with the other surface, the surface exert the force perpendicular to, right? So it is a contact force, right? So what is the example of the normal reaction? Let's say that I have this pen, right? So if I uh, remove my hand, right? If I leave my hand through this pen, so this will drop down, right? So this will
Yes,
drop,
sir.
right? Then, but if I put it, if I put this pen, uh, so this will scroll down, right? So if I put this pen like this, oh, this is rolling. So I should have, yeah. So if I put this pen, this is also experiencing the gravitational force, right? I have to
Yes,
choose,
sir.
I have to this mobile, right? So I will not throw this mobile down, but if I put it down like this, right? Then it is not dropping down. Why it is not dropping down? It is still facing the same amount of gravitational force, but it is not dropping down. Why?
Sir, because it is getting holded.
It is getting holded, but why? How it is getting holded? Something is stopping it something is stopping it to drop down, right? What is that thing that it is stopping to drop it down? What is that thing? This surface. This surface is stopping it to be dropped down, right?
Yes, sir.
So
Yes.
which means that this surface is exerting some force, right?
Yes, sir.
And that force is acting upward, in the upward direction. So that force is acting upward direction, and that is balancing the gravitational pull downwards, right?
Yes, sir.
So that is what we call the normal reaction. Okay. So did you guys get the idea of the normal reaction?
Yes, sir.
Okay. So let's say that we have, right, we have an object which is kept like this, right? So this is in contact with this surface, right? So this will experience some force in the upward direction. This is what we call the normal reaction. Clear?
Yes, sir.
And let's say that if the two objects are touching, right? So they are contacting the surface. So this will have the normal reaction in this way due to this surface, and due to this surface, the object will have a normal reaction in this, right? Clear, guys?
Yes, sir.
Yes.
And let's say that we have these two surfaces, right? So we have these two surfaces. So let's say this is some wall and this is the ground. And some stair is put like this, right? So what is the contact point where this is contacting the surface? This stair is contacting the surface. Yeah. So at
Sorry,
which
sir.
point, at which point this stair is contacting the surface? So at
The last.
these 2 points, right?
Yes, sir.
So this will apply some normal reaction in this direction, in the perpendicular direction, right? This is N1. And this will also apply some normal reaction to this direction. Clear? Is this clear, guys?
Yes, sir.
So these are the example of normal reaction. Did you guys understand these points? Is this clear to you guys?
Yes, sir.
Okay. And the third one is the tension that you guys are having, right? In understanding the physics, you guys are experiencing some tension, right? So that is not about that force. The tension is applied by the string. Okay. So it is applied by string opposite to the direction of the mass which is attached. Right. So let's say that you have this string and some mass is hanging with this string, right? So the tension will be opposite to the direction of the mass. Okay. Let's say that you have these two strings. This is M1 and this is M2. So this is tied with this string. So this will experience the tension in this direction, and this will experience the tension in this direction. This is clear.
Yes, sir.
So these are the three common forces in our nature. Okay, please note it down. And we also have friction and buoyancy and other kind of forces, but we will talk about them later. But these three forces are the common or most common forces, right? So yeah, we'll do the numericals based on these kind of forces. Okay. And whenever, do you guys have any doubt in these three forces?
No, sir.
Okay, then please note it down. Whenever you guys have completed noting it down, please tell.
Finished, sir.
Finished.
So can you scroll? Yes. Sir.
Noted up to this point. Should I scroll down?
Yes, sir. Done, sir.
Done. Okay, so you understood that we have gravitation which is applied by Earth. We have normal reaction which is applied by surface, and we have tension which is applied by string, right?
Yes.
And for our case, we are considering that the mass of string is zero, negligible, right? So we are considering that this mass is negligible. Okay, we are only considering the mass of these objects that they are attached. So these are the example of the common forces. Now the most, so this chapter is very important. And in this chapter, the very, what should I say? How many stars should I? So many stars. So this is called the free body diagram. This is called the FEG. Right. This is the most important part of this chapter. Right. So how do we draw the free body diagram? The first thing is we do is that we separate all the masses, right? And second thing is that we write all the individual force acting on, right? So let's say that we have a table, and or let me say it like this. So we have a pulley, right? And in this pulley we have two masses which are hanging, right? So how many masses are there? Or should write separately write all the masses. So we have two masses in this case, right? So what we'll do is that let's say this is one object and this is two objects. So we will write one object here, right? And then we will write the second object here. And the second thing we do is that we write all the forces acting on that object, right? So these are the things that we do in the free body diagram. Is this clear, guys?
Yes, sir.
Yes, sir.
Okay, please note it down. And you guys will see that what is the importance of this free body diagram. Please note it down, and then we'll start the next topic.
Finish, sir.
Finished. Everyone finished? Completed, guys.
Just one second. Yes, sir.
Okay.
Yes, sir.
Noted.
Yes, sir.
Okay. So the next thing is equilibrium. Right. What is this equilibrium condition? So whenever on an object the total forces acting on it cancels each other out, which means to say that F net is Z. Then the object would be called in equilibrium. For example, let us take this example. So we have a book which is kept on the table, right? So this is the surface of the table, and some book is kept, right? So how many, if we draw the free body diagram of this book, so we have this book, right? So how many forces are acting on this book? Yes. How many forces are acting on this book?
Sir, one,
One. What is that?
gravitational.
Gravitational. Okay, so one is gravitational, right? And this is mg. Okay. Don't we have any other force which is acting on that book?
Normal reaction also.
Normal reaction also. So we have normal reaction which is acting in this, right? So if we draw the free body diagram of this object, right? Let's say this mass is here. So one is acting, which is normal reaction, and the other one which is acting, which is mg. So you guys can see that this is in this direction and this is in the opposite direction. So these are balancing out, right? So F net is what? This is n minus mg, which is 0, right?
Yes, sir.
Which means that n equals to mg. So this is called the equilibrium condition. Understood? We'll talk about this in detail in the next class. So please note this point. Please write this down, and then